Welcome back to STS. In today's tutorial, we're going to work with inverse functions. The only way we can have an inverse function is if the original function is one-to-one. And what that means is for the life of the function, you must have unique y values. And that's seen a couple of ways. One way is by doing what's known as the horizontal line test. So let's take a look at a couple of examples. Let's say that we have our coordinate plane here, our xy plane, and let's say on one we have it's linear, we have a straight line, and let's say we have a second one, and on this second one let's say that it's quadratic, so we have a parabola. Alright, to tell if a function is one-to-one, we're going to take a horizontal line and we draw the horizontal line and we see it intersects our original function at only one location. If that's true for the life of the function, which it is here for this linear equation, then that means that this here is in fact one-to-one, because each of the y values are going to be unique for the life of this function. Now let's take a look at this quadratic function here. With this quadratic, if I draw a horizontal line, notice that this horizontal line intersects the function at two different locations. When we get to the vertex, it may intersect once, but again, this has to be true for the life of the function. So this one here is not one-to-one. So it must be one-to-one for it to have an inverse. So let's go ahead now and let's take a look at an example. Let's say that we have f of x is equal to 2x plus 6. Alright, there are a series of steps we need to follow to convert or to actually derive the inverse of a function. The first thing we need to do is, if the function is in f of x notation, we need to change that f of x into a y. So this here becomes y is equal to 2x plus 6. Second thing we need to do is to swap the x and y variables. So here this y becomes an x and this x becomes a y, and everything else stays in place. The third thing we need to do is to solve for y. So here let's go ahead and subtract 6 from both sides. In doing so, those cancel out. I'm left with x minus 6 is equal to 2y. I need to get this coefficient of 2 away from the y, so I need to divide each one of these terms by 2. So I'm left with x halves minus, 6 divided by 2 is 3. And here I've got 2 divided by 2, which gives me 1. So I've got 1 times y, which is just y. So the inverse here is going to be x halves minus 3. Alright, now the fourth thing we want to do is we want to do a check. Alright, with the check, it says if I take the original function and I input the inverse, the output is going to be the value x. And if I do vice versa, where I take the original function as not the original function. I take the inverse and I input the original function, then its output is also going to be x. So now let's give this a try. Let's start with the original function, and we're going to input the inverse. Here the inverse is x halves minus 3. And if we look at the original function, we see that it's 2 times x. Well, everywhere we see x, it needs to be replaced by this new input, which is x halves minus 3. And we finish off the original equation by writing the plus 6. And then we begin to solve. We need to distribute this 2 to each one of these terms. So here I have 2x divided by 2 minus, I have 2 times 3 to give me 6. And then I add 6. Now I simplify. 2 divided by 2 just leaves me with x. And then negative 6 plus 6 again is 0, which just leaves me with just x. Now I have to test it in the other direction, where I begin with my inverse, and now the input is going to be the original function, which is 2x plus 6. Now if I look at my inverse, I know that I have x divided by 2, but now x is replaced by 2x plus 6, where all that's divided by 2. And I continue by writing the negative 3 to finish off that inverse function. And again, I begin to simplify. I have addition over a common denominator of 2, which means I can separate this into two terms. So here I have 2x over 2 plus 6 over 2, and I continue with the original minus 3. And now I simplify. 2 divided by 2 leaves me with x. 6 divided by 2 leaves me with 3. I rewrite my negative 3. A positive 3 and negative 3 evaluate down to 0, leaving me with just a value of x. So here we see that with our check, in both directions we end up with x. And one last thing I wanted to say, or I forgot to say, is that if a function is said to have an inverse, that means that for the life of the function, each one of the ordered pair are switched. So for example, if the original function had an ordered pair of 4, 7, then the inverse is going to have a location at 7, 4. And notice how the domain, or the input of the original function, is now the range of the inverse. And if we look at the range of the original function, or the y value, we see that there is now the input, or the domain of the inverse. Alright, that sums it up for this video by Speller Tutorial Services. Please subscribe to that YouTube channel, and as always, thank you for watching.